My name is Christelle Colin Leitzinger, and I am a data analyst at Muffin Cancer Center. What I'm going to talk about today is how we might move toward a more personalized medicine for ovarian cancer using radiogenomics and radiomics. So ovarian cancer is a deadliest gynecologic malignancy in the US. At present, there are no standard of care biomarker to inform the first-line treatment regimen best suited for patients. To identify pre-treatment computed tomography CT-based radiomic feature predictive of survival among women with high-grade serous ovarian cancer and reveal potential underlying biology associated with this feature. We included 298 women diagnosed with this cancer who were evaluated at Moffitt and had pre-CT scans. So we extracted the radiomics feature from this CT scan and used a decision tree adapted for survival time, and which was able to stratify these patients into low risk and high risk group. And the most informative radiomics feature is called ROI volume center of mass, COM, in X direction. So this stratification was able to separate survival into high and low risk. So with high risk here, with worse survival. We did observe that in the training and in the test cohort, but we didn't see the same effect in the neoadjuvant cohort. That is done on overall survival, and we observe the same thing for PFS. We then realized RNA analysis, and we saw in continuous and dichotomous analysis a change of expression of some gene, like an increase of AKT2, the oncogene protein, and PSMC4, the proteasome 26S related protein. And then we performed a gene set enrichment analysis where we identify the oxidative phosphorylation pathway as significantly associated with this feature. So we saw a change, regulation of the most gene in OXPHOS, and also a correlation, negative correlation, between this gene and the radiomic feature. So, in conclusion, we observe we found this radiomic feature come in the X direction, which is more informative for overall survival among patients with this type of tumor, treated with upfront surgery. But this was not associated with patients treated with neoadjuvant chemotherapy. The radiogenomics analysis identified two genes, AKT2 and PSMC4, as significantly associated with this feature. And we also found that the oxidative phosphorylation pathway is one of the gene sets most negatively associated with this feature. This is really important, as other studies show that activation of the OXPHOS pathway may be related to an increased response to conventional chemotherapy, suggesting that OXPHOS may be a key pathway for chemoresistance in ovarian cancer. Of course, we need further research to elucidate more the biology behind what we saw and also to confirm our findings. So I just want to thank, obviously, my Moffitt and for the funding they give us, and also my awesome boss, Lauren Perez.